Hello everyone! I have some examples here of solving systems of equations, which just means you have two equations or more. That's what a system is. We're going to be doing just two equations, and we're going to solve by graphing, by substitution, and by elimination, which is also called, in some books, linear combinations, but it is the same exact thing. So the first method we're going to do is by graphing. So the first thing, I need to take each line and get y alone. So 5x plus 2y equals 7. I can subtract 5x from both sides. So then I have 2y equals negative 5x plus 7. Divide everything by 2, just like this. So y equals negative 5 halves x plus 7 halves. And now we can graph this line. So the first thing is the y-intercept. It's 7 halves, which you could think of that as 3.5. So on the graph, I'll go up to 3.5. So that would be right there. And then I need to graph the slope, negative 5 halves. So I'll go down 5 to the right 2. So down 5 to the right 2 would take us to there. Let's count it one more time. Down 1, 2, 3, 4, 5 to the right 2. That'll take us there. Okay, and I'm going to wait to connect those because maybe I'll need another point. So now I'm going to take the other line and get the y by itself. Okay, so I just made a little more room for it. So this line, 3x minus y equals 13. I will subtract 3x from both sides. So negative y equals negative 3x plus 13. Divide by a negative 1 all the way across. So then y equals 3x minus 13. So same thing. I'll plot the y-intercept first, which is negative 13. That's going to be all the way down here. Let me just make sure. 2, 3, 4, 5, 6, 7, 10, 11, 12. Yep, negative 13. And then the slope is a positive 3. So I will count up 3 over 1. Up 3 over 1. Up 3 over 1. And let's do one more. Up 3 over 1. Now you can probably see where they're crisscrossing. I'll try to draw this as straight as possible. So here is the line that I just graphed. Okay, and then here was the first line. Okay, and then you can see that they are intersecting each other right here at that point. And that point where they crisscross or intersect is the solution. And the coordinates of that point are positive 3, negative 4. So that is our solution. So positive 3, negative 4. That's our answer. Okay, now we're going to do exactly the same problem, but by using the substitution method. So it'll show you how you can get exactly that same answer, but without graphing. Graphing is fine, but it's not really the greatest way, especially if the solution is a decimal or a fraction, because it's just, you're not going to be able to see exactly where the two lines are crisscrossing on the graph. So, but with substitution, you would be able to get the exact answer. So with substitution, I usually locate the variable that doesn't have a coefficient in front of it, which in this case is this y right here. And then I work on getting that y alone. So I'm going to take this equation, let's just write it over here. 3x minus y equals 13. And I'm going to get y alone, so I subtract 3x from both sides. So negative y equals negative 3x plus 13, and then divide everything by a negative 1, just like we did on the first page. So y equals 3x minus 13. All right, now what I do is I plug that into the y in the other equation. Don't plug it right back into the y in the same equation, or you'll just get like 0 equals 0. So this right here, this expression for y, is going to go into the y in the first equation. So I'll bring this down here. 5x plus 2y, but the y is the 3x minus 13, equals 7. And now I have one equation with only x in it, so I can work on solving. I'll distribute the 2. So 6x minus 26 equals 7. So 11x minus 26 equals 7. So add the 26 over. So that gives us 11x equals 33. Divide both sides by 11. So x equals 3. So that's our x. And then the best place to plug this x back in is where you already got the y alone. Most students go to plug back into one of the original equations, and that just causes you to have more work. So plug this x in right there, because y equals 3 times x, which is 3, minus 13. It's all ready to go. Y is alone. So 9 minus 13, y will equal negative 4. And you see we have exactly the same answer as we did with the graphing method. So 3, negative 4 is our final solution again. Okay, and then same problem, but by using the elimination method. So with the elimination method, one thing you can always do it this way. You want one variable to be opposites. Like, for example, if there's a 4y, then you would also want in the other equation a negative 4y, because then once you get that, you will add the two equations. Okay, so that's like the rough idea of what we're doing. So looking through here, if I got the x's to be opposites, I'd have to multiply the top equation by 3 and the bottom equation by negative 5. And in that situation, I would have 15x on top and negative 15x on the bottom, which is fine, but that's a lot more work than we really need to do. Let's not do that, because I'm looking at the y's, and if I just multiply this equation by 2, by the time I get over to the y, when I distribute this, it'll be a negative 2y, which is perfect because there's a positive 2y in the top equation. So that's what I'm going to do, and I need to distribute it to everything. So just recopy the first equation, because we're not changing that at all. Now distribute the 2 through the second equation, so 6x minus 2y equals 26. And then, this is the step where I said over here, then add the two equations. So we're adding vertically. So 5x plus 6x is 11x. 2y minus 2y is gone. It's 0. And then 7 plus 26 is 33. So these numbers are probably looking familiar. Divide by 11 on both sides, so x equals 3. That's our x. And now, the substitution method, I told you there's the one really great place to plug the x equals 3 back into. With the elimination, there's not really as clear-cut of a good place. So why don't we just take it, and I'll just arbitrarily pick this x. So I'm going to plug 5 times the x value, which is 3, that we just found, plus 2y equals 7. And then I can solve this. 15 plus 2y equals 7. Minus 15, minus 15, so 2y equals negative 8. Divide both sides by 2. Y equals negative 4. And so the solution, again, is 3, negative 4. And that's it. So there's advantages to each method. Graphing is great, especially if the answer is nice integer values. Not so nice if it's decimal values, because then it's hard to see on the graph. Substitution, let's click back to that. Substitution, if you get to pick which method you're using, I would use substitution if one variable doesn't have a number in front of it, which that number is called the coefficient. So when you scan through a problem, if you're getting to decide which method, if you see an equation like 3x plus y equals 11 and like 7x plus 12y equals 20, I just randomly made those up, I would be scanning through and noticing this y right here that doesn't have a number in front of it. And that would be the prime time when you could use substitution, because then you can easily just subtract 3x to get the y alone, like this, and then you're all ready to go to plug that in to the other y in the second equation. So that's a great time to use substitution. And then a lot of my students really like to use elimination because things are so nicely lined up with each other, like the x's are right there, the y's are right there, and then you have equals to the numbers right there. So a lot of my students prefer that method, and that's fine. You just have to go through and maybe multiply one equation or both equations so that you get opposites with either the x's or the y's. And that's it.